Okay, let's work through page 45 and 46. This will be our quiz review. All right, so number one, this is everything is power rule here for number one, but we do need to spend time expanding out, cleaning up, converting radicals to rationals, variable in the denominator to numerator. So our first step is just to see if we can expand our way through and get every term ready for power rule. So go ahead and try number one. Oh, when it says dy dx, again, that just means find the derivative of my equation y with respect to x. All right, so try that first step. You're going to distribute that 7x cubed through. You're going to push out that 3/11ths in front of the x squared. You're going to rewrite that radical as a rational exponent, and then you're also going to bring that radical up to the top and convert to rational exponent as well. And so here's our first step. And this first step has no calculus in it. We're just rewriting the terms so that we can actually do power rule, right? Because power rule comes with its restrictions. Maybe that 3/11 x squared is not causing so much trouble. You guys can see that 3/11 can come out, but I've seen students where they see a problem like this. They don't know what to do. They're like, how do I do power rule? So anytime you see a number in the denominator, push it out as a coefficient, and that way it just feels like a number in front rather than staring at a number below. So. All right, are we good up to this point here? So there are no calculus, but every term is now ready for power rule. So now we can do power rule, right? So power rule, go ahead and try that. Now the next line, we can call it dy dx or y prime, and now I can do power rule. So bring the exponent down, multiply with the number in front, and then subtract 1 from the original exponent. Okay, so try that for each term. Let's see how we do. Okay, next line, we find the derivative now, 28x cubed minus 21x squared. Bring down the 2, we get 6/11x plus 4 pi. This is really just a number, right? This is like 8x. 8x becomes 8, so 4 pi x becomes 4 pi. 5 pi to the 4th, that looks like a variable, but that's just a number. So this doesn't become 20 pi cubed, this just becomes 0. So I know pi is a symbol, but it is not a variable, it's just a number. So any constant's derivative is just going to go to 0. X to the 4/5 becomes 4/5, x to the -1/5. Students have trouble usually with square root of x to the 7th, so make sure that we understand that's x to the 7/2. Not 2/7, not 1/7, but 7/2. And then we bring that up to the top as x to the -7/2, bring that down. We go through power rule now, so -35/2, x to the -9/2. Okay, so we are at our answer. We just have one more step to do, and that is to resolve the negative exponents. So any negative exponent, we're going to push them back down to the denominator. Everybody good with number 1? Number 2, it says write the equation in tangent line, but since it's first find f prime, our function is x plus 4 over x squared minus 2. So to find the derivative, look at how this is set up here. You got a numerator over a denominator, and there's multiple terms in the denominator. What rule do we have to go through to find the derivative? Yeah, quotient rule. So we'll do f prime times g minus fg prime all over g squared. Let's try that. Okay, once we have our derivative, it says simplify fully. So I'm going to distribute the 1 through, distribute the -2x through, but we can't cancel these out, right? We're breaking rules if we do that. So I'm putting the 2x in front of the with the negative so that I can just do it all at once. I would distribute the -2x through. on page 45. So now that we have our f prime, we can find the tangent line equation. So tangent line equation requires order pair and slope. Order pair, it will come from your original function. Slope will come from your derivative. And then we can put in the point slope form. All right, number 3, find the derivative of the function and evaluate the slope of the graph at x equals 1. So we have 2 sets of parentheses. We could FOIL everything out, but we could also use what? What rule can we also use? We have 2 sets of parentheses being multiplied with each other. Product rule, yeah. So let's try that. Try going through product rule for number 3. Any questions with 2? So my first parentheses, I'll call that F. The second parentheses, I'll call that G. And we'll just do F prime G plus F G prime. You may want to rewrite your expression with a rational exponent so that you can get it ready for power rule. Remember, pi is just a number, so 5 pi's derivative is just going to be 0, right? Okay, so here's my F prime times G plus FG prime. And now how can I find the slope of the graph at x equals 1? How can we use F prime? plug in what? So slope is derivative, right? So we can just do f prime of 1. So it's messy. So as long as you replace your x value with 1, you can leave all this mess, and that's considered f prime of 1. You can leave your answer in this form. Don't have to clean anything up. So whatever that number is, that's going to be the steepness of however this graph looks at 1. Okay, last page, page 46. Number 4, particle moves along the x-axis, so that its position at time t is given by x of t, where x of t is in feet per second and t is greater than or equal to 0. Include units with your answer. The part A says find the velocity and acceleration functions. So go ahead and find each of the derivatives. Find the first derivative, well, I'll give you velocity. Find the second derivative, that will give you acceleration. So velocity is just 3t squared minus 18t plus 15. Acceleration, a of t is just 6t minus 18. Part B, what's the velocity at 2 seconds? So we can just plug 2 into the velocity function. Our derivative allows us to find the exact slope requiring only one argument value. And what's our unit going to be for velocity? Yeah, feet per second. So make sure that you're always reading your directions or what's provided, because it's not always going to be feet per second. It could be, meters per hour. It could be kilometers per minute, right? So make sure you read what your units are. Okay. And what is our acceleration going to be in terms of the units? Acceleration will be what? Feet per second or feet per second squared, right? All right, any questions up to part C? Part D, put a star next to this one. This is the trouble spot that students experience. Find the average velocity of the particle from 3 to 8. We are not going to use velocity function for this because average velocity is defined as the change in position over change in time, we're just going to find the slope of the position function. So we're going to find the position at 3 seconds. We'll find the position at 8 seconds. And we'll just figure out how much distance does this object cover divided by how much time has passed. And that will give us the average velocity. So I want us to understand why this is an easily missed problem, because we see that word velocity and our tendency is, well, it says velocity, so why not use velocity? If it says find the instantaneous velocity at a moment in time, then you'll use a velocity function, but average velocity is defined as change in position over change in time. So the acceleration, sorry, the velocity function will not give us what we need for this problem. So we find the position at 8 seconds, we find the position at 3 seconds, we're just plugging them into the original function. And I'll give you easier numbers to work with on the quiz since you won't have a calculator, but we're just doing change in position over the change in time, but our units will still be in terms of feet per second because it is still a rate of change of position. We're still taking that distance and dividing it by how much time has passed. Okay, part E, when is a particle at rest? What does that mean? V of t is 0. Yep, so go ahead and set your velocity equal to 0, solve for t. Okay. And 1 second and 5 seconds because velocity is equal to 0. Once you find your velocity function, factor out of 3 and then continue with trinomial factoring, we get 1 and 5 seconds. Okay, question so far? All right, part F, when is a particle moving right? When is particle change direction? We're going to create a sign line, create a velocity sign line. So we're going to use information from part E to answer part F. So particles at rest at t equals 1 second and 5 seconds. So before we can figure out when it's moving left or moving right, let's create our velocity sign line. We'll put 1 and 5. What else should we put onto the sign line? 0. Why is that? Because that's the starting point, right? That's a restriction. That tells us that we're not going to be having to worry about any negative intervals because this problem, the timer starts at 0. So now we're going to find test numbers in each subinterval because we want to find out the direction of motion in each subinterval. So I'll test 1/2. I'll test 2, and I'll test 6. And where do these numbers go? Position or velocity? velocity. Yeah, we want to find the direction of motion. If you plug 1/2, 2, and 6 into the position, you'll find out where the object is, but it's not going to tell you which direction it's moving. So I like to put it into the factored form of velocity. You can do other versions, but this is the easiest one to plug into, especially without a calculator. So we're just going to gather the signs. Okay. All right. 1/2 minus 5. Is that positive or negative? Negative, right? 1/2 minus 1 is also negative. So 2 negatives makes positive. So moving right. Plug 2 in. 2 minus 5 is negative. 2 minus 1 is positive. Negative times positive is negative. If I plug 6 in, positive, positive. Okay, so when is a particle moving right? At which interval? 0 to 1. And then 5 to infinity. Because our justification is because velocity is greater than 0. Now, there's something very subtle here. This is actually not correct. There's something about the interval that is not quite right. So it could be a comma or a union. Either of that is fine. Something with the parentheses. Yes. Bracket where? 0. Why do we put a bracket at 0 here? Equal to 0. That means that the particle is not stopping at 0. It's only stopping at 1 and 5. It just so happens that we're starting the timer at 0. So if I plug 0 into the velocity function, 0 minus 5 is negative. 0 minus 1 is negative. 2 negatives makes positive. So when the timer starts, the particle is already moving. So because we're including 0 as a part of our domain, it's already moving to the right. So a bracket includes our interval. That's a little. Now, if it was just greater than, then we have then we use parentheses. But the greater than or equal to forces us to at least have to test 0, and we find that the object is already moving at 0 seconds. Okay, when does the particle change direction? So change direction at 1 and 5 seconds because there's a change in signs as well. A particle change direction at t equals 1 and 5 seconds because v of t changes signs. Okay, let's talk about displacement and distance. Displacement is the easier of the two formulas, of the two problems here. Displacement is just my final position minus my initial position. Okay, it looks kind of like average velocity, just without the denominator part. It's just changed, just where am I, how far am I from where I started? Okay. So I'm going to find my position at 2 seconds, find my position at 6 seconds, and do my position at 6 seconds minus my position at 2 seconds. So if I plug 6 into my position function, I'll get negative 25. So that means 6 seconds in, this object is located at negative 25 on the x-axis. 2 seconds in, the particle is at negative 5 on the x-axis. So between that time period, how far has he gone? So negative 25 minus negative 5. So that negative 20 feet indicates that this particle is going to be 20 feet to the left of where it started. If we're looking at where he's located at 2 seconds versus where he's located at 6 seconds. I see some students want to divide by x6 minus 2, but this is not slope. This is just displacement. It's just final position minus initial position. Right, any questions with part G? Okay, distance is a little bit more involved, so let's look at part H. Part H says, what is the total distance from 2 to 6 seconds? Okay, so we're still going to find the position at 2 seconds and 6 seconds. Let me just put that here. We're still going to use that information. So at 2 seconds, he's at -5. At 6 seconds, he's at -25. But the thing with distance is that we know that there is a potential that the particle is going to backtrack. So 2 seconds in, he's going to be moving left, and then he's going to stop and turn around and move to the right. So we have to make sure that we have to count his steps. So every step he takes, doesn't matter whether he's moving left or right, we have to include that as part of our counter. So what that means is we need to also find the location where he changes direction. We also need to find out where x of 5 is. So x of 2 is -5. X of 5, if I plug 5 into the position function, I'll get -32. And then x of 6 is -25. So I think the easiest way to think about this is imagine you're on a line, and every line, and then that x-axis, you're on the x-axis, and every step you take will take you to the next integer value. So that means at 2 seconds, he's starting off at -5, and then he's going to go walk all the way over to -32, and then he's going to walk back to -25 on the x-axis. So we're starting here, walking here, and then we're turning around and walking back. So just imagine how many steps is it going to take for me to walk from here to here, and then also how many steps will it take for me to walk back to -25. So I just subtract these two numbers, right, to figure out how many steps I've taken. So between -5 and -32, how many steps is that? -27. So you've taken 27 steps to get from here to here. And then how many steps will you take from -32 back to -25? Seven. So how many steps have you taken in total? 34. 34 feet. That's your total distance. Some students, they want to add these numbers together, but that doesn't make sense, right? Because we can't take negative steps. So just think, okay, I'm standing at this location, I'm walking to this location. How many steps will it take to get there? And even though I'm walking backwards after that, I'm still counting steps. So every step I take, whether it's to the left or to the right, will go towards a positive counter. I see some students, they want to include every number, but you only have to worry about a point where he changes direction. We don't have to test 3, 4, any. That just feels like overkill. We just have to worry about where he starts, when he's going to change direction, and then where he ends, and then just figure out how many steps by subtracting those numbers. Okay, part I, is the speed increasing or decreasing at t = 4? So increasing, decreasing speed, we have to compare signs between what? Acceleration and velocity. So we find acceleration at 4, we find velocity at 4, and we look at their signs. If they're both the same signs, then speed is increasing. If one is positive and the other is negative, then speed is decreasing. And because velocity is negative and acceleration is positive, speed is decreasing since velocity and acceleration have opposite signs. Part J, put a star next to this one. This one is troublesome for students, just like how average velocity is. It says, is velocity increasing or decreasing at t equals 2? It looks like the wording here, except instead of speed, it's replaced with velocity. But this one, we don't compare signs. What do we look at? Is velocity increasing or decreasing? Do we look at the velocity function? We look at acceleration. Why is this not velocity? Why is it acceleration? What turns this into an acceleration description? Increasing, decreasing, right? This is asking about the rate of change of velocity. It's not asking if velocity is positive or negative. It's asking, is velocity increasing or decreasing? That's the rate of change. So we just look at the sign of acceleration. Okay? Whatever the sign of the acceleration is, that's going to give us our indication of whether velocity is increasing or decreasing. So positive acceleration would mean velocity increasing. Negative acceleration would mean velocity decreasing. So at t equals 2, acceleration is negative. So therefore, velocity is decreasing. So put a star next to D, put a star next to J. As you can imagine, those are the ones that are most easily missed because some of the words are misleading. Okay, so we went through a full quiz review. There's one more type of problem that I haven't gone over. I'll do that with you tomorrow. We are going to start our next unit, but we'll have plenty of time to do more quiz review. Did everyone pick up a handout? Okay, so if you haven't picked up a handout, go ahead and pick one up in a second. I did worksheet 3 this morning, but tomorrow I'll highlight some problems from worksheet 3. The key is attached for worksheet 3 and worksheet 4. And then Thursday morning, I'll have a help session going over worksheet 4. And this is what your quiz will look like. The front page will be power rule, product quotient, tangent equation, and the back page will just be like this, where you have a stem position function, and you're asked about all these different parts. Okay. All right, come get your phones. Check your calendar. There's homework from AP Practice tonight.